Hello everybody. So some of you were asking about building a system to talk to the PDF. So this video is all about that. I will be showing you more than that. So please bear with me. There are various approaches to do this, but I will tell you the easiest one. And with a similar approach like my previous video. If you haven't seen my previous video, please go and watch to better understand this. So there are two approaches to do this. One, using the OCR. By using the OCR, we can just extract the text from the PDF and save it in the TXT file. The similar approach we have done in our previous example, by where we just extract the text from the URL and kept it in the text file. After that, everything remains the same. I guess under the hood, LangChain does the same. But if you are too lazy to do this, so you can use OpenSource PDF loader that the LangChain provides, which can be imported from LangChain.document loaders. After that, you will just load your PDF document into the OpenSource PDF loader and load it in the document variable. The process after this remains the same, exactly like we have done in our previous video. Here I have used my resume to do this. But one problem I found doing this is that there is no pre-processing of the text. As you can see, we cannot remove next line and some other character from the text. Or maybe I am doing it wrong. But our model is not that powerful as OpenAI, so result might be inaccurate. And we don't have much control on the whole process. Like we have just loaded our document in the OpenSource PDF loader and everything is done by the LangChain. So to solve this problem, we can build the entire pipeline by our own. To build the entire pipeline, let's understand how the LangChain app worked in the journal. At the first, we just have load our document by using the loader.load. Then we just have split it into the multiple chunk. Here the chunk size is 500. The next, we use a semantic search to encode our chunk to the vector. Here we have done by using embedding and semantic search in those vector later on. After that, we have retrieve a top case semantic search result when we pass the query in it. Then we just pass the chunk into a QA model along with the query we have done semantic search by. Here the QA model is Google Flantify. So as a LangChain user files for the semantic search, we can leverage that in our benefit. Here is the repo of the files I just found online. You can just study the repo to create your one semantic search. But let's see how we can use it to create our one. Let's understand by an diagram. We can see we have a document. For now, the document is a PDF. We can just extract the text from the PDF using an OCR. The text then can be broken down into multiple chunks. Chunk 1, chunk 2 and chunk 3. The chunk either can be encoded by using any word-to-vec model. You can just use embedding from the sentence transformer or any transformer you like, including the BERT transformer. The chunk vector can be stored into the vector database like ChromaDB or Pinecone. Then we just semantic search on those by using the files. After using the semantic search, we just get an top key result from it. As our LLM is basically a QA model, we need to pass its context and a query to get an result. So this is how the entire process of a LangChain works. This works for every practical example, including the chatbot, where we can create an infinite memory for it. To create an infinite memory in a chatbot, the similar approach can be taken. Only thing is we don't have document this time. We have a chatbot which include history. The history can be extracted by using the response from our previous chat. And if we use semantic search on those chat, then we can just pass history to it and the response from the user to generate the response from our model. This way, the infinite memory can be done for chatbot. So this is all I want to show you in this video. Thanks for watching and subscribe if you like my video.